to the variable. In our last video, we looked at sets, how we gather and group distinct pieces of data. But once you have data, how does a computer actually make decisions with it? How does a game know when to trigger a game over screen? How does an app know you've typed the wrong password? It all comes down to logic. And in discrete mathematics, logic starts with a single building block called a statement, sometimes called a proposition. A statement is a sentence that is strictly true or false. Think of a statement as a sentence that passes a binary test. It has to be definitively true or definitively false. There are no middle grounds, no room for opinion, and no mystery. Let's look at 3 examples to see what actually a statement is and looks like. Canberra is the capital of Australia. Go clean your room. And chocolate is the best cake flavor. Let's test line number 1. Canberra is the capital of Australia. Is it true or false? It's a fact. It's true. Because it has a definitive truth value, this is a logical statement. Line number 2. Go clean your room. Is that true? Is it false? It doesn't make sense to ask that. It's a command, an order. Because it can't be true or false, it is not a logical statement. Line number 3. Chocolate is the best cake flavor. Now, you might love chocolate, but someone else might like vanilla or strawberry or a red velvet cake. This is a subjective opinion because its truth changes depending on who you ask. It is not a statement in discrete mathematics. In algebra, we use variables like x and y. We talked about variables and sets in the first episode, so if you have not watched that yet, I recommend you watch it before watching this episode. In logical statements, we do use variables, but a bit different one. So, logical variables. We use, generally speaking, we use P, Q, and R. Think of these variables like Lego blocks. We take a big statement, shrink it down into a single letter, and then we can snap them together to build complex logic. So let's look at an example where this notation is used. Let's suppose P equals it is raining. And Q equals the grass is wet. Right now, these are simple statements. They stand alone, but the real magic happens when we start using grammatical operators to connect them into compound statements. If you've done any coding at all, you've already used these operators. In maths, they just have unique symbols. Let's break down the core form. First up is known as negation. The symbol looks like a tilde. All it does is flip the truth value. If P is raining, then not P means it's not raining. So in the previous example, we looked at that P was equal to raining. But if it's not P, that means it's not raining. Next is and, known as conjunction. The symbol looks like an upside down V. For an and statement to be true, both pieces must be true. If it's raining but the grass is dry because it's covered by a roof, the compound statement P and Q is completely false. So P and Q has to be equal to it is raining and the field is wet. To be true. Third is or, known as disjunction. The symbol is a right side up V. In math, this is inclusive or. It means piece A is true or piece B is true or both are true. It only takes one single true to make the whole thing true. So if we take the P and Q example, the only difference will be it is raining or the field is wet. And if either one of them are true or both of them are true, that means the whole statement is true. Finally, we have the conditional if then or implication. And the symbol is a arrow, which means an if then implication. If we write P arrow Q, we are saying if it is raining, then the grass is wet. The first part is a condition, and if that condition is met, the second part is guaranteed to happen. This arrow is the backbone of how computers follow instructions. Every single time a computer program checks a condition to send a notification, authorize a password, or trigger a game over screen. It isn't just running software. It is executing this exact discrete mathematics and evaluate these logic statements to control exactly what happens next. Thanks for watching the variable. Hit subscribe, grab your notebook, and I'll see you in the next one.